Integer linear programming can be used to solve a project selection problem. Here we have a firm in a situation to select projects for a period of 5 years from a set of 6 projects. Capital investment required for each project is also provided for each year. For example, project A requires an investment of 3 million in the first year and does not require any additional investment in the subsequent years. The NPVs of the projects are also provided. The problem here is that the firm cannot select all of these projects because it is working under some constraints. The first set of constants belong to the capital requirement each year. So here is the capital requirement for the first year, which is the sum product of capital required and asset reject. This is it. And here is the capital limit for the 4 years. The fifth constant is that project D and E are mutually exclusive, or in other words, they can't be accepted together. If one is accepted, the other should be rejected. The sixth constant is that up to a maximum of 4 projects can be selected. And the seventh constant is that project A and C must be selected or rejected together. And the last constant is that project D depends on project B. Next, we have to formulate our distance situation. A binary value of 1 means the project is accepted, and a binary value of 0 implies that the project is rejected. So if I reject all of these projects, the sum of the NPVs will become 0. So the NPV has now become 0, and the capital requirement for each year will also turn into 0. If there is no project, there won't be any capital requirement. In this problem, our objective is to maximize the summation of NPVs. In this cell, the formula is the sum product of NPVs and corresponding accept and reject decisions, which are expressed either as 0 or 1. After setting the decision situation, now we will go to the solver function. Our objective is to maximize the sum of NPVs of projects for the firm. So the cell that contains the formula of summation of NPVs will be selected to be optimized. We want to maximize NPV by changing the binary values that can only take the values of 0 and 1. Next, we have to define the constants the firm is facing. The first set of constants is the capital limit for each year. So this can be defined in the first 4 constants can be defined in just one formula. So here is that constant. And our next constant is that project D and E are mutually exclusive. So the summation of D and E should be equal to or less than 1. So we will select the cell that contains D plus E. Its value should be less than or equal to 1. Now the next constant is that only 4 projects can be accepted. So the value of this cell should not exceed 4, or it should be less than or equal to 4. Now our next constant is that project A and C must be accepted or rejected together. So our A minus C should be equal to 0. And now our next constant is that project D depends on project B. This can be defined as D minus B, and D minus B should be less than or equal to 0. And finally, we will set our last constant, that the variable of accept and reject can take only the values of 0 and 1. Or in other words, this variable is a binary variable. Now the capital budgeting problem has been formulated and defined. We just need to click the solve button. So let me click here. Here is the solution that is suggested by the solver. So it is suggesting that we should select all these projects except project D. And the maximum NPV possible in the given constant is 10 million. So this is how projects can be selected.